A cable is considered as a deformable linear object. By saying so, we can find out that it is very difficult to model such objects because they change their shape in the environment, and that will be difficult if it is difficult to be modeled. It will be difficult for having classical robotics controller to manipulate such object in the environment. But here comes a need for having a new AI paradigm modules where we work with data-driven approaches. Today we are trying to work on a problem of cable harness routing, and this problem is, as I say, it's complicated to be modeled in the world. So we need to collect data from experts who are doing the manipulation of the cable in the harness, and then pass that to the neural networks or to AI models that are going then to imitate this motion without explicitly modeling the motion of the cable itself, but learning from the data that we acquire. Today we have sub-centimeter accuracy. We are not into the millimeter accuracy in this type of paradigm of work. We're opting to have such results later, but as well we are limited by the input that the expert is going to give to the system. So if they are not very accurate, our system will not be very accurate as well, because it learns a little bit of the errors that is being induced in the data. So today, as I mentioned, we were working on the cable harness routing problem. We achieved some good initial results in manipulating an object that is deformable like the cables in a way that AI was able to learn from the data. We are targeting in this problem aeronautics and automotive industries, because the harness problem is existing a lot in these industries. Yet we need to go a little bit further in our work to achieve the tough requirements of these industries in their repeatability and many other factors before deploying it to real factories. Our work indeed consists in three major steps. The first step is to collect the data, and in this case we use GELLO for the moment, and there are other techniques that can be used to teleoperate the robot and to do the tasks by an expert human. Then we give this data, that's a teleoperation of the robot, plus the vision feedback, plus the tactile feedback, the sense of touch, to a computer model that's going to learn for some time, and then we will generate I consider as an artificial brain or an artificial neural network that will then go to the stage 3, where after it learned, we put it into the test. We deploy such model on the robot, and like that the robot will do the task autonomously.